Hello everyone, in this video we are going to integrate e to the power x into sin x dx. So first we assume e to the x sin x is something. Let's say I. Let I equals integral e to the x sin x dx. So now integrating by parts. We know the formula for integrating by parts is that integration of uv dx is equals u integration v dx minus integration of differentiation of u into integration of v dx and dx. Okay, we apply this formula where we take u equals sin x and v equals e to the x. Okay, so integrating by parts, we'll get I equals sin x integration e to the x minus integral of derivative of sin x integral of e to the x and dx and dx. Okay, then we know that the derivative of e to the x is again e to the x, so this becomes e to the x sin x minus, we know that the derivative of sin x is cos x. Okay, so here the integral becomes e to the x cos x. So here the integral becomes e to the x cos x and dx. So here is our I equals e to the x sin x minus e to the x integral e to the x cos x dx. So here another integral from the first one, e to the x sin x dx, and here integral of e to the x cos x dx. So we let this integral as j. Okay, so now we assume the second integral as j. So I equals e to the x sin x minus j. Okay, now we calculate j as I. Okay, where j is equals integral e to the x cos x dx. Okay, now j is equals integral e to the x cos x and dx. So again we integrate by parts by integration of uv formula, integrating by parts. Then similar way, cos x is here u and e to the x is v, u integration v dx minus integration of differentiation of u integration of v dx and whole dx. Okay, so I think okay, I wish you all see here j equals cos x integration of e to the x dx minus derivative of cos x integration of e to the x dx and whole dx. Okay, so now what will be j? And j equals the integral of e to the x is e to the x and cos x minus derivative of cos x is negative sin x, so here negative sin x, and integration of e to the x is e to the x and here is dx. Okay, so j equals e to the x cos x plus integration e to the x sin x and dx. And here we substitute I equals e to the x sin x. Here you can see this is our problems this is our integral e to the x sin x, and we put this as I. Okay, and our target is to find the value of I. This is I e to the x sin x dx. That means we get the I again in repeated way. Okay, so we can write j equals e to the x cos x plus I. Okay, so we substitute the value of j in the above equation. Let this is equation 1. Let this is equation 1. Let this is equation 1. So we substitute the value of j in equation 1. Then we can find the value of I, and our target is to find the value of I. Okay. So I equals e to the x sin x minus j. I equals e to the x sin x minus j. So using value on equation 1, using value of j in equation 1, what we'll get? Using value of j on 1, what we'll get? We get I equals e to the x sin x minus j, and j is e to the x cos x plus I. So the whole things becomes e to the x cos x minus I, and we take minus I on the left hand side, we get twice I, right? Twice I equals, here e to the x is common, e to the x sin x minus cos x. Okay, so I equals e to the x over 2 sin x minus cos x. And since our integration is completed, we take plus c as integral constant. Okay, we take plus c as integral constant, and we suppose I equals the value of I is integration e to the x sin x dx, and the value of I is this, and the value of the integral is e to the x over 2 sin x minus cos x plus c. Okay, where c is integral constant, and our integral is completed. This is the final answer. Okay, thank you for watching the video.